Skew lines are 3D lines that do not intersect and are not parallel, like this. What you're going to solve for is the rubber band that bridges between the two lines. Let's pause here and grab your sketchbook. In this challenge, Bridge L1, L2, we are going to be finding the 2 points, one on each line, that are the closest possible to each other. In the application project Streetside mapping, we will be using this to find the closest points on 2 lines from 2 cameras. For this algorithm, we are given L1 and L2. Our result will be the shortest bridge that connects them. Let's quickly visualize these lines. We'll say L1 goes this way and L2 goes that way. So the bridge will look kind of like this. It's a line segment constructed by the 2 points on the lines that are closest to each other. We'll call these 2 points P1 and P2. This is what we're really looking for. How are we going to go about this? Let's quickly look at the visual again and take note of the direction of the bridge. If we project this onto 2D and focus on just L1 and the bridge, we see that they're perpendicular. The same thing goes for L2, so now we know that the bridge is perpendicular or orthogonal to both lines. And how do we find a direction vector orthogonal to 2 given directions? That's right, cross product. Okay, so we've got our cross product vector. Now what? Well, a way to get a point is by the intersection of a plane and line. The problem is, we can't just make a plane using the orthogonal vector as the orientation, because then it would never intersect with the other line. Instead, we can use it as the run direction in the module extrude plane from a line. Let's call this plane PL and draw it on top of our sketch. As I explained earlier, this plane is going to be extruded using line L2 and the cross product vector, using the new z-axes under the z-align rotators from each line. As I mentioned earlier, our method will be to find at least one of the points using the intersection of this plane with L1. So let's write that down too. Technically, we could do the same thing for our second point P2, right? Well, yes, but that would mean we'd have to extrude yet another plane and find the intersection. Let's revisit the core of the problem, finding the shortest bridge between the skew lines, which are defined by the points on the lines closest to each other. Doesn't that sound familiar? It should. We have already constructed a module for finding the closest point on a line. For P2, we will simply use that module inputting P1 in line 2. Our final result will be the bridge, a line segment defined by P1 and P2. And this is what our final result should look like. When I move around the lines, it should compute the shortest line segment between the 2 lines. And then it'll kind of just look like this. When you bring them together, the line will be a lot shorter because there's less of a distance. And when they're farther apart, it's a longer line. Now we're going to work on a really cool application of the algorithm you just solved. You can proceed with the project guide PDF and start sketching how the 3D mapping is going to work using stereo cameras on a moving vehicle.